If you're a space fan, you've probably wondered, what happens when two of the densest stars in the universe crash into each other? It's a question that has fascinated astronomers and science lovers for decades, and the answer is even more mind-blowing than you might expect. Imagine two objects, each with more mass than our sun, but squeezed into a sphere just a few miles across. These are neutron stars, and when they collide, the universe puts on a show that's as dramatic as it is mysterious. Grab your curiosity, because we're diving into one of the wildest cosmic events ever. This isn't just a simple crash. This is a cosmic ballet, a dance that takes millions, sometimes billions of years to reach its grand finale. The story of colliding neutron stars is a tale of gravity, time, and the very building blocks of the universe. First up, what's a neutron star? To understand the drama, we need to know the players. A neutron star is what's left behind after a massive star explodes in a supernova. The core collapses under its own gravity, crushing protons and electrons together to form neutrons. What's left is a city-sized sphere of pure neutron matter, so dense that it defies our everyday understanding of physics. It's the collapsed core of a massive star, so dense that a single teaspoon would weigh about 1 billion tons. To put that in perspective, that's heavier than Mount Everest, packed into a spoon. The gravity on the surface of a neutron star is so intense, it would crush anything in an instant. These stars are also magnetic monsters, with magnetic fields trillions of times stronger than Earth's. Now, picture two of these ultra-heavy stars spiraling closer and closer, pulled by each other's insane gravity. They might have started as a pair of massive stars orbiting each other, both ending their lives in supernova explosions, and then becoming neutron stars locked in a gravitational embrace. Over millions of years, they lose energy, inching ever closer together in a slow-motion dance that's invisible to the naked eye, but monumental in scale. As they dance, they send out ripples in space called gravitational waves, kind of like cosmic earthquakes. These waves are distortions in the very fabric of space and time, traveling across the universe at the speed of light. When scientists first detected gravitational waves in 2015, it opened a whole new window into the cosmos. The collision of neutron stars is one of the most powerful sources of these waves, and their detection allows us to hear the universe in a way we never could before. But when they finally collide, boom, it releases more energy in a single burst than our sun will in its entire lifetime. The collision is so violent that it briefly outshines entire galaxies, sending shockwaves and light across the cosmos. For a few seconds, the universe is lit up by a flash of gamma rays, the most energetic form of light, in what's known as a gamma ray burst. These bursts are so powerful, they can be detected from billions of light years away. This cosmic clash creates a spectacular explosion called a kilonova. A kilonova is much brighter than a typical nova, but not quite as bright as a supernova. It's a rare and beautiful event, painting the universe with colors we can barely imagine. The light from a kilonova can linger for days or even weeks, giving astronomers a chance to study the aftermath and learn more about the forces at play. During this explosion, matter is thrown out at incredible speeds, up to 1/10 the speed of light. The temperatures soar to billions of degrees, and the pressure is so intense that atoms are smashed together, creating new elements. This is where the universe gets creative, forging some of the rarest and most precious materials known to humanity. It's so powerful, it forges rare elements like gold and platinum, literally sprinkling them across the universe. Every gold ring, every platinum watch, every bit of these precious metals on Earth owes its existence to the titanic forces unleashed in neutron star collisions. The atoms in your jewelry were born in the heart of a cosmic explosion, scattered across space, and eventually swept up into the clouds of gas and dust that formed our solar system. And that's not all. The story doesn't end with the explosion. The aftermath of a neutron star collision is just as fascinating as the event itself. The debris from the explosion can form new stars, new planets, and even new life, given enough time. The energy released can trigger the birth of stars in nearby clouds of gas, seeding the universe with the ingredients for future generations of cosmic wonders. Sometimes the collision can even form a black hole, a region of space where gravity is so strong, not even light can escape. If the combined mass of the two neutron stars is great enough, their merger collapses into a black hole, warping space and time around it. This black hole can continue to grow, swallowing up anything that comes too close, and becoming one of the most mysterious objects in the universe. The formation of a black hole is the ultimate endgame for these cosmic collisions. The gravitational waves produced in this moment are some of the strongest ever detected, giving scientists clues about the nature of gravity, the structure of space-time, and the origins of the universe itself. So next time you wear gold jewelry, remember, it may have been born in the heart of a neutron star collision. The gold on your finger is a tiny piece of a cosmic story that began billions of years ago in a place far beyond our solar system. It's a reminder that we are all connected to the universe in ways we're only just beginning to understand. Scientists around the world are still studying these incredible events, using telescopes, satellites, and gravitational wave detectors to catch every detail. Each new collision we observe teaches us more about the universe, how it works, how it evolves, and how the elements that make up our world are created. Space is full of wonders, and this is just one of its wildest shows. The next time you look up at the night sky, remember that somewhere out there, two neutron stars might be spiraling toward their spectacular fate, ready to light up the cosmos and shape the universe in ways we're only beginning to imagine.